Good evening, dear students. Okay. So yes, so many are joining now. So let us start. Okay, so today we are going to start with the next topic. So the fourth chapter, okay, in your syllabus, that is chemical bonding and molecular structure. Okay, so chemical bond. What do you mean by chemical bonding? Yes, you might have studied about chemical bonding. So here we are going to discuss some of the important uh, uh, concepts, okay, in the chapter chemical bonding and molecular structure. So what do you mean by chemical bonding? What is a chemical bond? Yes. So let us see what do you mean by chemical bond. Okay. So chemical bond, what it refers to the when you have two or more atoms. Okay, when you have two or more atoms, or when you have molecules or ions. Okay, so they give rise to what? They combine. They combine and they form what? They form a chemical compound. Okay, how these chemical compounds are formed? So when two or more atoms combine, okay, or when two or more molecules combine. Okay. Now, so this bond between which is present between this chemical compound, okay, that is nothing but a bond. Okay, that is a chemical bond. So the bond which is present between the chemical compound, it is called as the chemical bond. So there are different types of uh, chemical bond. Okay. Or you can also what you can state the chemical bond as the force of attraction. Okay. Now between the atoms or an ion. Suppose I have a compound like HCl. Okay. I have H2O. Then I have methane. Okay. So the bond, what is involved in HCl? Hydrogen atom and chlorine atom. Okay. So the bond which is present between this atom, the force of attraction which is present between these atoms is nothing but a chemical bond. Okay. Now there are different types of bonds. So what are the different types of bonds? So this bonds may be present between same types of atom, okay, or between different uh, atoms of different molecules. Okay, so between same atoms of same molecule and between the atoms of different molecules. So let us see, so which are the four types of different bonds which you are studying in this chapter. So ionic bond, covalent bond, coordinate bond, and metallic bond. So these are the four different types of bonds, okay, which we are discussing in this chapter, chemical bonding and molecular structure. Now, what is this ionic bond? Anybody knows what is the ionic bond? Yes, in ionic bond, what takes place? If I give you an example of an ionic compound, it is NaCl. Okay, NaCl. So what happens here? Transfer of electrons takes place. Okay, your transfer of electron takes place in the ionic bond. So what takes place? Transfer of electrons takes place. Okay. Now sodium. If you write the electronic configuration, it is 1s2, 2s2, 2p6, 3s1. Okay. So it has one electron in its outermost shell. So what it will do? It will give that one electron and it will form Na plus ion. Okay. It will form Na plus ion and Cl. Okay. Whose electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So it requires one electron so that its octet is completed. Okay, it is stable. So what it will do, it will take that one electron from this sodium. Okay, so sodium gives the electron, chlorine accepts the electron. So this transfer of electrons, okay, transfer of electron is nothing but the ionic bond. Next is covalent bond. What do you mean by covalent bond? Covalent bond is what? It is a mutual sharing of electron takes place. Okay, suppose I have a H2. Okay, I have a dihydrogen. So hydrogen has one electron. This hydrogen has one electron. So the mutual sharing of electron takes place. So equally the electrons are distributed. So this is called as a what? It is called as a covalent bond. Next is a coordinate bond. What do you mean by coordinate bond? Coordinate bond is present between now suppose a center metal atom is there. Okay, a central metal atom is there, and the ligands are there. Okay, so this type of bond is present in the coordination compounds. Okay, so like this, so it is like a arrow towards it. Okay, so suppose I have ligands. So okay, like this ligands are present, so it might be a so different arrangement of is possible. Okay, so like this, so that is a coordinate bond between so a metal and the ligands. Okay, so ligands will share or it will donate the lone pair of electrons. Next is a metallic bond. Metallic bond is present where? Metallic bond is present between the metals. Okay, it is present between what? It is present between the metals. Okay, it is a force, it is like a electrostatic force of attraction. It is like what? It is like a electrostatic force of attraction. Okay, between an electron and a positively charged uh, ion. Okay, so this is about the four types of bonds. Then, so these are the types of bond between the atoms of same molecule. Now, the type of bond between the atoms of different molecule. Okay, so there are two types, hydrogen bond and the van der Waals force of attraction. So these are also two types of bond. Hydrogen bond, okay, it is present between the hydrogen and the electronegative atom like your nitrogen, oxygen, okay, etc. So this is a hydrogen bond. So in again hydrogen bond, there are two types, intramolecular hydrogen bonding and your intra and intermolecular hydrogen bonding. Okay, so these are some hydrogen bonding is a one type of bonding. Okay, and then another is the van der Waals force of attraction. Okay, van der Waals force of attraction. It is also a type of force of attraction. Okay, between the atoms or molecules. Okay, so so this is also it is called as the London forces. Okay, London forces. So van der Waals force of attraction. So just I am giving you a slight idea about these types of bond. Then in this chapter there is something called as Koshal-Lewis approach. Okay, so Koshal-Lewis approach is nothing but you are writing down the electrons, how the electrons are distributed. Okay, the valence electrons, you are writing the Lewis structures. Okay, you are writing the Lewis structure. So this theory, it basically tells you or it explains you how the bonds are formed. Okay, after arranging the electrons, okay, the outermost electrons, it explains you how the bonds are formed. Now here, whatever the bonds are responsible, these are the valence electrons. Okay, so the whatever the valence electron, what do you mean by valence electrons? What do you mean by valence electrons? The electrons which are present in the outermost shell. Okay, the electrons which are present in the outermost shell. So these are responsible for the bonding. Always, whenever the bonding takes place, so which electrons are responsible? The valence electrons are responsible. Valence electrons means the outermost electron. Now suppose if I give you sodium again, so it is 1s2, 2s2, 2p6 and 3s1. Okay, so which is the outermost valence shell? So it is 3s1. Okay, so one electron here. And suppose I have chlorine, so which is the valence electron? 1s2, 2s2, 2p6, 3s2 and 3p5. Okay, so your 3p5. So 3s2, 3p5 is the valence electrons, okay, which are involved in the bonds. Okay, so like this. So valence electrons means the outermost electrons. Fine. Then inert gases. So whenever you have, what do you mean by inert gases? So inert gases are those gases, the noble gases. Okay, so all the inert gases, they have the noble it is having the configuration of Ns2Np6. Okay, but helium is one such noble gases which has a duplet state, that is 1s2. Okay, So all the helium, all the noble gases, they have a octet state. Octet means what? 8 electron in its outermost state, and they are said to be stable. Okay. And your helium is in the duplet state, duplet configuration. And these all noble gases, they are chemically inert. Okay, they are inert. Why they are said to be inert? These electrons are not involved in bonding. Inert means these electrons are not involved in bonding. Okay, and because of the 8 electrons in the outermost shell, these are having a what you say, stable configuration. Okay, then whenever you have less than 8 electron, okay, these 8 electrons, they are other atoms. Okay, the other atoms, they are only the noble gas configuration, only the noble gas metals. Okay, and they have the octet configuration. Rest all will have less than 8 electrons. Okay, fine. These noble gases, they are chemically reactive. Okay, these elements are chemically reactive and they take part in chemical reaction, and they attain by octet configuration. So the elements, what they try to do, they try to be in their octet configuration. Okay, and they try to balance their octet rule. They okay, they will try to obtain the octet rule. So there are some this rules. Okay, so octet, how the octet configuration can be achieved, either by losing electron or by gaining electrons or by mutual sharing of electron. Okay, so either giving and taking of electron, that is by forming a ionic bond, or by sharing mutually the electrons, that is by the what it is called as covalent bond. Okay, so like this, the octet configuration can be involved. So core electrons, so that is, what do you mean by core electrons? Now the word core electrons, core electrons means the electrons which are uh, uh, inside. Okay, inside, or now suppose if I tell you, if I take fluorine. Okay, if I take fluorine, so 1s2, 2s2, 2p, 5. Okay, 5. So here, which are the inner core electrons? So this 1s2, okay, the electrons, they are called as the inner core electron. So these core electrons, they do not participate, okay, in the bonding. Okay, so always the atom, that is your valence electrons, they participate in the your this, okay, in your bonding process. So we have discussed what is ionic compound. Okay, again, I'll not explain in ionic compound. So just remember that in ionic bond, okay, it is an electrostatic force of attraction. Okay, and it involves electrostatic force of attraction between the ions. So one forms a cation, another will be forming a anion. Cation means the element will have a positive charge, and anion formation means it will have a negative charge. Okay, and always the cations are smaller in size and the anions are larger in size. Okay, so so this is about the ionic compound. Okay, so what are the properties of ionic compound? These are crystalline solids. Okay, they have a generally high melting point, they have generally high boiling point, and they are excellent conductors. Okay, and they are generally soluble in water. So ionic compounds are generally soluble in water. Next is Born-Haber cycle. Okay, very important concept from this particular chapter, that is Born-Haber's process. So what does a Born-Haber cycle tells you? It tells you about the formation of an ionic compound, okay, from a reaction of a metal. So, okay, so this is the your Haber's process. Okay, Haber's process, it involves the formation, okay, that is, first it involves the so it goes via different steps. Okay, you cannot measure directly, you have to calculate the lattice energy at each every step. Okay, by and this is an indirect method, it is not a direct method, it is a indirect method. The Born-Haber cycle, it depends on the Hess law. Okay, that is, it involves the formation of an ionic crystal, that is by direct combination of element or by different steps are involved. Okay, so these are the different steps. Just go through. So this is the Born-Haber cycle. Okay. Next, we have discussed about what is covalent bond. Yes, we have discussed just now what is covalent bond. It is nothing but sharing of electron takes place. Okay, mutual sharing of electron takes place. Then next we have also discussed about the coordinate bond. Okay, coordinate bond. Next important concept is the bond parameters. Okay, bond parameters. So what are the bond parameters which you need to know? The bond length. Okay, bond length means what? The distance between the two bonded atoms in a molecule. Okay, that is called as a bond length. So you can calculate the covalent radius or the van der Waals radius. Okay, so radius about the covalent radius, van der Waals radius, we have discussed in our previous chapter. Okay, what is covalent radius? It is the half the distance, okay, between the center of a nucleus to the outermost electron. Okay, and van der Waals radius is what? It is also the half the distance between the two similar adjacent atoms, okay, of the nearest neighboring molecules. Okay, then important concept is the VSCPR. Okay, next is VSCPR theory. So VSCPR theory, in short, I'll tell you, it tells you about the shape of the molecule. Okay, it tells you about the shape of the molecule. So here, suppose I have a metal and three ligands. Okay, or I'll take a so metal and that is metal and you have A3. Okay, Ma3 type of compound. So here the bonds are arranged in such a way that there is a not repulsion. Okay, they are completely apart from each other. Okay, so the bonds, okay, of in a molecule, they will adapt such a arrangement that they are far from each other. Okay, so like this, the VSCPR theory, it tells you it focuses on the shape of a molecules. Okay, and the shape of the molecule, it depends on what? It depends upon the valence shell electron pairs, whether bonded electrons are present or non-bonded electrons are present around the central atom. Okay, so it depends on the number of bonded and number of non-bonded electron. Non-bonded means what? Non-bonded means lone pair of electrons. Okay, and bonded means the electrons which are participating in sharing of electrons or mutual transfer of electrons. Okay, so that is your shape of the molecule. So this is the first point of the VSCPR theory. Then that only, again, as I told you, the electrons, they are arranged in such a way that there should be minimum repulsion between them. Okay, and always the lone pair repulsion is more in compared to lone pair and bond pair bond pair. So this you have to remember about the valence shell electron repulsion theory. Okay, then so this was about the valence shell electron pair repulsion theory. Next is about VBT. Okay, VBT, this VBT tells you about the valence bond theory. Okay, so here what happens here? Overlapping of atomic orbitals takes place of the valence shell of two atoms. Okay, and they result into a bond. Okay, and that bonds, it acquires a pair of electron with opposite spins. Okay, so here it depends on the greater the overlapping, greater will be the bond strength. So how? So here the bond VBT. Okay, it depends on the type of overlapping. So here the two types of overlapping takes place. One is the head-on overlapping, and another is the head-on overlapping, and another is the like this. Okay, that is a sigma bond and a pi bond. So so perpendicularly like this, the your overlapping takes place, and this is called as the head-on overlap. Okay, so so this results into two types of bond. One is a sigma bond and another is the pi bond. Sigma bond is a strong bond. Okay, and pi bond is a slightly weaker bond. Okay, so this is about the valence bond. Uh, Next is hybridization. So different type of hybridization takes place depending upon the type of electron pair, bond pair. Okay. So these are the different geometry. Just go through this tabular. Okay. So very important chapter. Okay. This is a very important chapter. So very important concepts are there. Okay. So next is MOT. So MOT also. Okay. So MOT, so it is a molecular orbital theory. Okay. So your whatever the atomic orbitals are overlapping, so that will form equal number of molecular orbitals. Okay. So here when an electron in an atomic orbital is influenced by one nucleus in a molecular orbital, it is influenced by two or more nuclei depending upon the number of atoms of the molecule. So how much ever the number of atomic orbitals are involved, that many molecular orbitals are involved. So here two types of this or forms. One is a bonding molecular orbital, another is anti-bonding molecular orbital. Okay. Bonding molecular orbital is of lower energy, anti-bonding molecular orbital is of higher energy. Okay. So these are some of the important points from your molecular orbital theory. Okay. So based on that, you have your how to calculate the bond order and all. So how the questions will come. So like that, we will go through this. Okay. So next we have discussed about the hydrogen bonding and metallic bonding also. Okay. So as an so this was some of the short notes, okay, on your chemical bonding and molecular structure. So as and then how the questions will appear. So like that, we will discuss in brief about the uh, concepts. Okay. I hope this is clear. Yes. Is it clear? Shall we proceed for the questions now? Okay. So let me take the questions. Are you able to see the questions? Yes. Okay. So this is the question. I hope it is visible. Okay, fine. So let us start. So the number of nodal planes present in sigma star antibonding orbital is. So this is a question from MOT. Okay, so MOT, that is molecular orbital theory. So the number of nodal planes present in sigma star antibonding orbital is. So options are A0, B3, C1 and D2. Yes, anybody knows what is a nodal plane? The number of nodal planes present in antibonding S. Okay, that is sigma star S orbital is. Yes, try to answer if you know. So here, how is the molecular orbital overlap takes place? The molecular orbital of sigma star S, okay? How it is formed? Sigma star, okay? So it is the S orbital. So overlapping of S orbital with another S orbital, right? So two spherical S orbital overlap takes place. Now, so how it is? So suppose this is 1s, this is 1s, okay? So this anti overlapping takes place. How the overlapping takes place? So S orbital and this S orbital, it will overlap, okay? And so this is how many nodes are present here. So this is the node. Okay. So node is the region where the probability of finding the electron is 0. So how many? So this is a one nodal plane is present. Okay. So this is a one nodal plane is present between the sigma star 1s. So the molecular orbital, that is sigma star S is formed by what? It is formed by subtraction of overlapping of two S orbitals. Okay, so here how many nodal planes you can see? There is one nodal plane. Okay, option number C. You can see there is a one nodal plane. Yes, Hema has answered it correct. Very good. Option number C is the correct answer. So others also please try to answer. So what is nodal plane? It is a region where the probability of finding the electron is zero. So when you are finding out the nodal planes in sigma star S antibonding orbital, antibonding means the energy of this antibonding orbitals is quite higher, but it is unstable. Okay. So that is sigma star antibonding orbital. How this overlapping takes place? It overlapping takes place by subtraction. Okay, subtraction of the two s orbitals. So there is a one nodal plane present. Fine. Yes. Okay. Let us go for the next question. The overlapping of orbitals in benzene is of the type. So what is the type of overlapping which is taking place in benzene? So how is the structure of benzene? Okay, let me demonstrate the structure of benzene. So we represent benzene how? So benzene is a symmetrical, okay, like this. So C6, H6, right? C6, H6 is the, what is this? This is the benzene. So what is the type of overlapping takes place? Okay, that is C6H6. So what you have here? So when you see the, this is also the from the question MOT. Okay, so this is from the concept MOT, that is molecular orbital theory. So here, according to molecular orbital theory, okay, when you see of benzene, so here each carbon, okay, each carbon is what? It is carbon. Carbon is C6. Okay, that is 1s2, 2s2, and 2p2. Okay, so it is sp2 hybridized. So each carbon here it is sp2 hybridized, and you can see what is the angle which is present. It is 120 degree. Okay, so this is a sp2 hybridized carbon. So you can see the arrangement of the okay. So here your hydrogen is having s orbitals. Okay, hydrogen is combined with the s orbital, and your carbon is having the sp2. Okay, so each carbon here is what? It is a sp2 hybridized. Okay, and the bond angle is, you can see the bond angle between each carbon is 120 degree. So you can see how many carbons are here. 6 carbons are there, right? 6 carbons. So there are two pz atomic orbital. So each on each carbon atom there is one p orbital. Okay, and this p orbital, it is parallel with each other and they are perpendicular to the plane. So how they are? You can see they are parallel to each other and they are perpendicular to the plane of the ring. Okay, so it is above and below. You can see it is perpendicular. Okay, so these they are perpendicular to the plane of the ring. So here what you can see that so you can see that it is having like double donut shape. You can see the shape of the double donut. So the above now if I represent here, okay, so if I represent here again, if I show you, so how the arrangement is, so this is the p orbitals. Okay, these are the p orbitals. So how they will form? So this will form above ring. Okay, this will form above ring and this will form below ring. Okay, how is the shape? It is like a double donut shape. Okay, and 6 carbon atoms, and all are what? They are delocalized. The pi electrons are delocalized. They form a cloud. Okay, so benzene ring is a planar ring. Above there is a cloud and down is one cloud. Okay, so the orbitals, what it is, the pi electrons are delocalized. Okay, so it is it is having sp2 sp2. Okay, sp2 sp2 type of overlapping. So the overlapping of the orbital is of what type? It is of the type sp2 sp2 overlapping. Okay, because each carbon atom is having what? It is sp2 hybridized carbon atom. So remember that what is the type of overlapping? Okay, in benzene, it is sp2 type of overlapping. Okay, so answer is option number A. So who all have answered is, yes, Hema has answered it as option number A. Others also please try to answer. Next question, the calculated bond order of superoxide ion. Okay, what is superoxide ion? O2 minus. So you have to calculate the bond order. How to calculate the bond order? Yes, how to calculate the bond order? Anybody knows how to calculate the bond order? So bond order, the formula to calculate is half, okay, half number of bonding electrons upon number of anti-bonding electrons. Okay, so a number of bonding minus number of anti-bonding electrons. So just take, this is a formula. Now we'll write the O2 minus. Okay, let us write the electronic configuration. So when you write in the molecular orbitals, okay, so how is the uh, electrons, okay, how the electrons are distributed. So sigma 1s2, sigma star 1s2, okay, so 2, 4, then sigma 2s2, sigma star 2s2, then the next electrons goes to sigma 2pz2 and pi 2px2, then which is equal to pi 2py2 sigma star 2px2, which is equal to sigma star 2py1. So this is according to the molecular orbital theory. When you put the distribute the this, okay, O2 minus. So each oxygen is having 8 electrons. Okay, each oxygen is having 8 electrons. So 8. So there are 2 oxygens. So 8 plus 8 is 16 and minus. Okay. So minus means again 1. So it is 17 electrons. So 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 electrons are present total. So when we are distributing, we are going to use this particular this, okay, like this the electrons are distributed. So now calculate the number of bonding and anti-bonding electrons. So these are the bonding. Okay, first we'll find out the bonding. So 2, this 2, okay, then this, and this. So how many are there? 2, 4, 5, 6, 7, 8, 9, 10. So number of bonding is 10 minus anti-bonding 2, 4, 5, 6, 7. So 10 minus 7, half of 10 minus 7. So half of 10 minus 7 is what? Half of 10 minus 7 is 7, 8, 9, 10, 3. Right? So 3 by 2. 3 by 2 is what? 3 by 2 is, so 1 by 5. Yes, everybody got option number A. I have got option number A. So remember how to find the bond order. Half into a number of antibonding electrons, number of bonding electrons minus number of antibonding electrons present in antibonding orbitals. Okay. So half of NB minus NA. So find out, okay, and calculate the this ions. Okay. So this was about the superoxide ion, how to calculate the bond order. Next is, among the following, the compound that contains ionic covalent and coordinate linkage is. The compound. So among the following, the options are ammonium chloride, NaCl, calcium oxide, and ammonia. Among the following, the compound that contains ionic compound, ionic covalent, and coordinate linkage is. Yes. Now you know what is ionic compound, what is a ionic linkage, what is a covalent linkage, what is coordinate linkage. Hema has answered as A. What about others? NaCl, the type of bond present in NaCl is what? What type of linkage? It is a, one will gain electron, another will lose electron. So this is a ionic bond. Okay. Then Then calcium oxide. Calcium oxide is a covalent bond. Okay. Calcium Ca. Calcium oxide is also a ionic bond. Okay. Calcium oxide is also a ionic bond. Then NH3. NH3 is a covalent bond. Okay. It is a covalent bond. Now when we see NH4Cl. Okay. If we see NH4Cl. NH4Cl. Okay. In NH4Cl, if I write the structure. So this is your NH3. Okay. This is your NH3. This is your NH3. So this is like a covalent as well as coordinate bond. Your NH3. When we see NH4Cl, okay, how is the bond? So N, H, 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 and one is the your coordinate bond. So here in NH4Cl, you can see there are three covalent bonds. Okay, there are three covalent bonds. So these are the three covalent bonds. So 1, 2, and 3. So three covalent bonds are present. 3 NH covalent bonds. Okay, and one, this is your coordinate bond. Okay, coordinate bond is present. One NH coordinate bond is present, and one NH4 plus and Cl minus. This is your ionic bond. So it is option number A. Okay. So again, I'll write it here. So N, H, 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 and this is H. So this is your what? So this is your three covalent bond, one coordinate bond, and NH4 Cl minus. Okay. So this is your NH4 plus and Cl minus ionic bond is present. So in NH4Cl, so option number A. In option number A, you can see that what type of bonds are present. One is the ionic, covalent, and coordinate. All the three types of bond is present in NH4Cl. While when we see the other example, okay, NaCl ionic bond is present. So this is wrong. Then calcium oxide also ionic bond is present. In ammonia, covalent bond is present. Okay, fine. Next question. Let us go for the next question. I hope you are getting the questions. Yes, no confusion, right? Okay. Let us go for the next one. A covalent molecule AB3 has pyramidal structure. The number of lone pair and bond pair electrons in the molecule are respectively. So this is based on VSEPR theory. Okay, this is based on VSEPR theory. So covalent molecule is there, AB3. Okay, it is having a AB3 type of compound. So this is a AB3. Okay, and is having a pyramidal structure. So this is a pyramidal structure. Okay. So the number of lone pair and bond pair electrons in the molecule are A 0 and 4, B 3 and 1, C 1 and 3, and D 2 and 2. So what is a bond pair? Bond pair means there is a bond pair of electron means sharing of electron. And lone pair means these are not involved in bonding. Okay, unshared non-bonded electron or lone pair of electrons they are called as. Yes, by seeing the structure, can anybody tell me? Yes, how many bond pairs and how many lone pairs are there? Yes, can you tell me what is the lone pair here? Which is the lone pair here? Yes. No, Neha, no. Not 2 and 2. Yes, anybody? Try. What is the lone pair here? So this is, okay, this is a lone pair. This is a lone pair of electrons. Okay. So this is a lone pair of electrons. So one lone pair is present. And how many bond pairs are present? Bond pairs is which? It is a sharing of electrons between the two atoms. Okay. Now here A and A. This is forming one bond. This is forming another bond. This is forming another bond. So there are how many bond pairs? 3 bond pairs. Okay. So one lone pair and 3 bond pairs. So which is answer C. I hope you have got it. Yes. So C is the answer. So the number of lone pairs and bond pairs electrons in the molecules are 1 and 3. Okay, lone pairs means what? These electrons are not involved in bonding. Okay, and bond pairs means these are involved in the bonding of electrons. Okay, equal sharing of electron takes place. Okay. So next is the correct statement with regard to H2 plus and H2 minus is. Okay, A, both H2 plus and H2 minus do not exist. B, H2 minus is more stable than H2 plus. C, H2 plus is more stable than H2 minus. And D, both H2 plus and H2 minus are equally stable. So with respect to so how to find whether H2 plus and H2 minus exists or no? Okay, we have the bond order. Okay, so bond order formula, that is half Nb minus Na. Okay, now H2 plus. H2 plus means what? H2 plus means two hydrogens. Okay, plus means minus one. So it is 1. Okay, so this is H2 plus. And H2 minus means H2 minus H2, 2 electrons, and minus means again 1 electron, so it is 3. So H2 minus. Okay, now let us put the values. So when we write the bonding, so it will be sigma, sigma 1s1. Okay, and here it will be sigma 1s2 and sigma star 1s1. Okay, so this is the filling up of electrons in the bonding orbital. Now put the values Nb. So this is 1 minus 0, and this is half into Nb is 2 minus 1. Calculate. So this is 1 minus 1 is half. Okay, so this is half, and so the answer is half, and this is what? 1 into this is also half. 2 minus 1 is 1, 1 into 1 is half. Okay, so even what you can see that, so the correct statement with regard to H2 plus and H2 minus is here. Okay, what is the, so you can see half bond order is present. Okay, half border and this is present. Now, when we see that the electrons present here is in bonding and here it is in anti-bonding. Okay, so even though the bond order, okay, these are equal, you can see that the bond order between the H2 plus and H2 minus are same. Okay, they are said to be equal. Why? Because both the bond order present is what? Half. But you can see that in H2 plus, it is more stable because the electrons are present in what? The electrons are present in bonding orbitals. Okay, in the bonding orbitals. So because of that, H2 plus is more stable, and the electron is present in the higher energy antibody. Here you can see in the H2 minus, the electrons are present in what? The electrons are present in anti-bonding orbitals, okay, which is of higher energy. So the answer is C. Okay, H2 plus is more stable. Both are having same bond order, but when we see the electrons are present in the bonding, and bonding orbitals are always stable as compared to anti-bonding orbitals. So H2 plus is more stable as compared to H2 minus, because the electrons in H2 plus, you can see they are in bonding molecular orbital, and in sigma, okay, sigma, when you have only sigma, that is bonding. When you have sigma star, that is called as anti-bonding molecular orbitals, and bonding molecular orbitals are more stable than anti-bonding. Bonding is of lower energy and sigma star is of higher energy, but this is higher energy but it is unstable. This is lower energy but it is stable. So H2 plus is more stable than H2 minus. So option number C is the correct answer. Okay, arrange the following in the increasing order of their bond order. So you have to arrange the increasing order of their bond order, that is O2, O2 plus, O2 minus, and O2 2 minus. So these are the four. Okay, so you have to arrange the bond order. Now you know how to calculate bond order. So bond order is equals to half number of electrons in the bonding minus number of electrons in the anti-bonding. Now O2 minus, okay, O2 is how many electrons are involved? Each oxygen, 8 electrons, another oxygen, 8 electrons. So it will be how much? 8 plus 8 will be 16, okay. Then O2 plus, O2 plus 8 plus 8 minus 1 is equals to 15 electrons. Okay, 15 electrons. So now we have to distribute this. First, I'll write everything. Then is O2 minus. O2 minus 8 plus 8 plus 1. Okay, so it is 17 electrons. Then O2 2 minus. Okay, next is O2 2 minus. That is 8 plus 8 plus 2 electrons. So it is 16, 17, 18 electrons. So let us put the electrons in the this, okay, molecular orbital electronic configuration. So for O2 is what? Sigma 1s2. Then the electrons goes to sigma star 1s2. Then it goes to sigma 2s2. Then it goes to sigma star 2s2. Okay, so how many electrons are involved now? Then it will go to sigma 2p z2. Okay, then it will go to pi 2px2 is equals to pi 2py2. Then it will go to sigma star 2px1 is equals to sigma star 2py1. Okay, so these are the electrons contribution. Now find out the bonding and anti-bonding. So how many bonding orbitals are there? How many bonding are there? Bonding means which will not have star. So this is 2, then 2, then 2, 2, this. Okay, so how many calculate? So 2, 4, 5, 6, 7, 8, 9, 10. So half 10 minus anti-bonding 2, 4, 5, 6. 6. Okay, so calculate. So half into 4. So 2 ones are 2. So it is 2. So in O2, in oxygen, how many these are present bonds? In O2 molecule, 2 bonds are present. So this is correct. Okay. So this we have found out. Similarly, can you put the electrons for others? Can you put the electrons for others? So that was 16 electrons. Now next is 15. 15 means I'll remove one electron from here. So it will be what? It will be sigma 1s2, star 1s2, 2s2, 2s2, 2p2, then pi 2p2, and pi 2px. Okay, now calculate now. Put the values now. I hope you have understood now. Yes. So put the values now. Half number of bonding 2, 4, 5, 6, 7, 8, 9, 10. 10 minus anti-bonding 2, 4, 5. Okay, 5. So this is half into 5. So how much it will be? It will be 2.5. Okay, so in O2 is how much? O2 is 2. O2 plus is 2.5. Next is O2, O2 minus. Okay, O2 minus, put the, how many electrons in O2 minus? 17. Okay, 17. Put for 17 now. Now already we have distributed. So here, okay, so sigma, this is 15. Okay, now again, if I want to write, so it will be pi 2px2, pi 2py2, sigma star 2p2 is equals to sigma star 2py2. Okay. No, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. How many? 17. So 1. Okay, you are, I will put 1. Now you calculate. Now you calculate the bond order. Same. Okay, how many bonding? How many anti-bonding are there? Put the values. So half bonding are how many? 2, 4, 5, 6, 7, 8, 9, 10, 11, 10. Okay, 10. Minus 1, 2, 3, 4, 5, 6, 7. 7. So it is half into 3. Okay, 3 by 2. So that is half. That is 1.5. So in O2 minus is 1.5. Okay, O2 minus is 1.5. Next is O2 2 minus. O2 2 minus means here 2 electrons will come. Okay, so only this change. So here it will be 8. Only here it will be 8. So it will be 2 by 2, that is 1. So this is 1. Can you arrange now? Can you arrange? So O2 minus, I'll write it here. Should I clear it? O2 minus is, O2 is 2. O2 is 2. O2 plus is 2.5. O2 minus is 1.5 and O2 minus is 1. Okay. Now they have asked to increasing order of their bond order. Increasing order means first will be a O2 minus, then will be a O2 minus, O2 2 minus, then will be O2 minus, then will be O2 and then will be O2 plus. So this is the increasing order, correct? So which is the answer? It is option number D. Everybody got the same? Option number D? Okay, Hema has got it, option number D. Others have understood. Is it clear? Bond order. So many questions we have solved on bond order. Now, did you understand about bond order? Okay. Next question. Which one of the following conversions involve change in both hybridization and shape? Okay. So these are the 4 conversions given. First is methane to ethane. Okay. That is CH4 to C2H6. Then next is NH3 to NH4 plus, C BF3 to BF4 minus, and D water to hydronium ion. So which conversion, when you do the conversion, there will be change in shape and size. Okay. Now, methane. Okay. When you see the shape of methane, it is a tetrahedral shape. It is a tetrahedral shape. This is a shape of the methane, which is a tetrahedral shape. Okay, this is a sp3 hybridized. This is sp3 hybridized. Okay, so this is tetrahedral. Then when you see ethane, okay, that is C2H6. So C2H6, C2, 1, H. Okay, so this is also what? This is also tetrahedral. This is also tetrahedral. Okay, C2H6. Next is your ammonia. What is the shape of ammonia? Anybody knows the shape of ammonia? Just now we have seen the shape of ammonia. It is a pyramidal shape. It is a trigonal pyramidal. It is called as trigonal bipyramidal. Okay, it is a trigonal bipyramidal shape, the shape of ammonia. And when we see the shape of NH4 plus, okay, NH4 plus, I'll write the shape of NH4 plus. Let me clear the other. Okay, NH4 plus. So this is the NH4 plus. Okay, so this is a tetrahedral shape. You can see the shape is like tetrahedral, like your methane. This is like methane shape. So this is a tetrahedral shape. Okay, next. So here you can see here what is the hybridization? NH3 is a sp3 hybridized. NH3 is a sp3 hybridized, and when you change the shape from sp3, it changes to from sp3 to, and this is also a sp3. Okay, your tetrahedral shape is also sp3. Next, BF3. When you see BF3, okay, if I write the structure of BF3, so boron, trifluoride, 2, 3, B, 1, F, F, F. Okay, so this is trigonal planar. Okay, BF3, trigonal planar, it is sp2 hybridized. Okay, it is sp2 hybridized. Then if I see BF4 minus, Okay, BF4 minus. So this is again same. It is a tetrahedral shape. Okay, this is a tetrahedral shape. BF4 minus. BF4 minus. This is what? This is your tetrahedral. Okay, this is tetrahedral. The shape here is sp3 and this is sorry, this is sp2 and this is sp3. Okay, so it is option number C. Option number C. What they have asked, which conversion will involve both the change in hybridization and shape. So your BF3 is a trigonal planar and the shape it is sp2, and BF4 minus is what? It is a your sp3 hybridized and it is a tetrahedral shape. So your both the hybridization as well as the shape is changing. If I see water, water is what? H2O. Okay, H2O. It is a bent shape. It is having an angular bent shape and it is sp3 hybridized. Then when you see hydronium ion, okay, H3O plus. Okay, H3O plus. So this is having what? This is having a tetrahedral shape. Okay, this is having a tetrahedral shape and sp3 hybridized only. So option number C is the answer. I hope you have got it. So this is based on again VSCPR theory. Okay, based on the VSCPR theory. So we have solved some 8 questions. Okay, remaining questions we'll be seeing in the next class. Any doubts up to here? Any doubts up to here? Yes. So go through the concepts again. So very important concepts. Okay, VSCPR, VBT, MOT. Okay. So based on that only. So today we have seen most of the questions on the theories. Okay, MOT and bond order. Okay, especially the bond order questions. How to calculate the bond order. Okay, how to distribute the molecular orbital electrons in the molecular orbital electronic configuration. So these all things please practice. Okay, a little confusing it is, but if you practice if you know the how to distribute the electronic configuration, okay, it will be easy. Okay, fine. So remaining questions I'll be discussing in the next class. Any doubts up to your? Yes, anything? If you have any queries, you can ask me. No doubts? Fine. So I'll end the session here. Okay. We'll meet in the next week. Thank you.